The next site characteristic that we're going to look at is our slope. On our map, it's just represented by a percentage. And first, we're going to look at the definitions to see what is actually defined as a slope. In OREGS 267-03, under maximum sustained slope in the regulatory definitions, it says that it means the change in elevation from the top of the bottom of a slope divided by the length of the slope expressed as a percentage, where the slope has a minimum length of 10 meters and where the slope is towards surface water. So what we're looking for are slopes that are directioned towards surface water that are longer than 10 meters. We're not talking little knolls or little dips in the field. We're talking about something substantial, more than 10 meters in length. And it is calculated by rise over run. So the elevation from the top to the bottom divided by the length. I have a little diagram here that we can discuss the formulas and the math behind it. So slope percentage equals rise divided by the run. So there's a few different tools that we can use. The first one doesn't require any math. It's called a clinometer. You look through the eyesight up there's two methods of doing it. One is to look up the slope. If you're going to do that, you stand right at the bottom of the slope, and we're going to say you're about 6 feet tall for easy figuring. You're standing at the bottom, and you're going to need something at the top of the slope equally as high as basically your eye level as to what you're looking through the clinometer for at. And so you can use a vehicle, you can use a stake, something of the sort just for a marker, something that you can see as you look up the slope at your marker. And that is going to, as you look through the site and you line up the line with your top of your marker, that is going to give you the percent slope. So that's a clinometer. It's small, it fits in your pocket, it's easy to use. The second method of using it is without a marker, and you look from the top of the bank and you move forward up to the edge of the hill as far as you need to go in order to be able to see all the way to the bottom. So if there's a lump halfway down, you're not going to be able to see to the bottom. So you'd only be able to see there. Okay, you'd know this because through your other eye, you would not be able to see the bottom of the hill. So you keep moving forward until finally, as you look down, you'll be able to see the bottom of the hill, just about like that. All right, you can line up all the lumps and you can see the bottom of the hill. That's how I typically used it. It eliminated the need for a marker, and typically it was more conservative rather than a slope isn't going to be one simple, easy plane. But as long as this is greater than 10 meters, that is in fact your maximum sustained slope versus eliminating that steepness because it's in the middle of another slope. Those are two methodologies that you can use to use the clinometer. Another one is simply a GPS. GPS reads out your elevation, so you can stand at the bottom of your slope, drop a waypoint, grab your elevation distance, and then you're also going to go to the top of your slope, drop another waypoint, and grab your elevation distance. And as the definition says, the change in elevation from the top to the bottom of the slope is your rise. So if this was the case, and say this was 500 meters above sea level, and we're going to say this is 510, which gives us a rise of 10 meters. So 10 meters is our rise. Next, we're going to use you can use your GPS. Your GPS should give you a distance between your bottom waypoint up to your top, but it does consider elevation. So it is actually, in fact, giving you this, this measurement, not your actual run. And so your GPS will do this as well as your rangefinder. You can point down the hill, and if you've marked where you took your elevation distance, you just simply measure the distance point to point. So that's going to give you your C side square. So in order to calculate your bottom side, the formula is a squared plus b squared equals c squared. So because we know c squared and b squared, it's actually going to rework the formula to be c squared minus b squared equals a squared. So if c squared was 50 meters with our rangefinder, and we know from our elevation distances on our GPS that it's 10 meters, we're going to use our calculator, and we're going to go 50 squared minus 10 squared equals, and then we're going to square root it. So our actual run is 48.98 meters. So we can round that to 49 meters. 49 meters. And then slope percentage equals rise over run. So we're going to go rise of 10 meters divided by our run of 49 meters. And we have a slope of 20%. So if I click, oh, that was wrong. 20%. I accidentally clicked the percentage there. So our slope would be 20% for this section if this was our slope. So what does that look like in the map? We can actually use our ag map to find similar rise over run measurements. This is the third and final method. I would always caution against this method because these are a tool, but accuracy is always better in the field. So right now, our typical topographical imagery has these topographical lines, and if you zoom in, that one said 495. Yeah, 495. It's kind of hard if I zoom in too far. This one says 500 right here. So what we can do for our surface water over here, knowing that there's surface water, the difference in elevation from the top of the bank to bottom of the bank would be 5 meters in this case. 500 minus 495 is 5. And so then we have to figure out the run, in which case we're going to go to the closest distance between these topographical lines, and it's 186.8. So if I go rise over run, so rise is 5 meters divided by the run of 186, we have a 2.7% slope. All right, and maybe we want to double check this one over here. That's pretty much the exact same, 187. And so we can be fairly confident that we have a 2.7% slope going by this map. Of course, you'd want to label your map maybe so that you know roughly which direction the slope is going. And you could write in here 2.7%. And then you would indicate which direction that slope was going. So you would put an arrow in here. And that slope was going down to surface water. All right. Now, our map has one final feature that is quite helpful in getting the smaller fine-tuning slopes. So as you can see, it's pretty difficult. There's a 496 meter zone in here and a 495 in here. So it doesn't seemingly look like there's very much difference of elevation in here. But we can get a little more detailed look by going to our derived layers and going to contours. So this makes the contours pop out at 5 meters. But if you look for a little bit more options, and then you zoom way close, this box down here pops up. It says click and drag to define areas to generate 50 centimeter contour data. So because there's not a whole lot of lines in contour lines in here, maybe we want a little bit more detail as to what the slope is doing in this corner with all this surface water. So we're going to use that selection box. We're going to select the area we want, and it's just generating those finer, smaller 50 centimeter contour lines. There we go. Now, this makes the map quite a bit busier. So it may be helpful, it may not be. You kind of have to really dig for the information. You can see that it goes up, it goes down. And so you're looking for contour lines of larger distance that are close together. This is just another tool. You measure the slopes the same, rise over run as the other, but it's just a slightly more detailed look. These are the three methods that I've used to measure slope. I hope that's helpful, and just as always, be sure to label things correctly on your map and ensure that you're double checking things in the field.